Chapter 13 Solutions. Exercise 13.77. A solution contains 3.73 grams of chloroform and 7.84 grams of acetone. The vapor pressure at 35 degrees of pure chloroform and pure acetone are 295 and 332 torr respectively. Part A. Assuming ideal behavior, calculate the vapor pressure of chloroform. Assuming ideal behavior, the vapor pressure of chloroform in this mixture is the vapor pressure of pure chloroform, 295 torr, multiplied by its mole fraction in this mixture. It's a bit tedious to calculate the mole fraction of chloroform because we're not given the number of moles of this chemical or the number of moles of acetone. So now we're going to set up the calculation for the mole fraction of chloroform. We have, I'm going to reuse this expression. We have 3.73 grams of chloroform. We need to convert it to its number of moles by having the mass divided by molar mass. Carbon has a molar mass of 12, hydrogen 1. Chlorine, I'm going to use 35.45 times 3 chlorine. This is the number of moles of chloroform. And on the bottom, the denominator should be the total number of moles of all components. We have two components in this solution, so we have chloroform here, and then I'm going to use a similar expression for acetone. For acetone, we have 7.84 grams. And then we need the molar mass of acetone. We have carbon, and then 3 hydrogen, and then carbon and oxygen, and then carbon and H3. Alright, we've got the mole fraction of chloroform, 0.188. Now we have this mole fraction of chloroform multiplied by the vapor pressure of pure chloroform. We'll get the answer for part A. So part A is the vapor pressure of chloroform above this solution, multiplied by 295. 55.4. Part B, assuming ideal behavior, calculate the vapor pressure of acetone. So we need to change this mole fraction to the mole fraction of acetone. One way is to replace the numerator for chloroform to the number of moles for acetone. Now we have the mole fraction of acetone here, which is 0.812. Now multiplied by the vapor pressure of pure acetone, which is 332, we get the vapor pressure 270. Assuming ideal behavior, calculate the total vapor pressure Well, we just need to sum up the vapor pressure of acetone and that of chloroform. So 55.4 plus 270. The experimentally measured total vapor pressure of the solution at 35 degrees Celsius was 309 torr. Well, it's different from 325. Is this solution ideal? No, it's not ideal. Because assuming ideal behavior, we should get 325. Now we have only 309 below 325. And this is because these two chemicals, chloroform and acetone, attract each other significantly. This significant attraction stabilizes both acetone and chloroform in the liquid phase. That makes the vaporization more difficult and the actual vapor pressure lower than the ideal value. We'll look at part D, fill in the blanks. Comparison of the value in part C, which is 325 to 309. This solution is not ideal. Chloroform acetone interactions are stronger than chloroform and acetone interactions. And this interaction is attractive. Overall, it's attractive, and it's more attractive than between two chloroform or between two acetone. That additional attraction stabilizes the liquid phase for both chloroform and acetone, which further lowers the vapor pressure of both chemicals.